Okay, I don't know about you, but I had so much fun last time. I want to try it again. How about that? Okay, let's do it. This is from the same source as the last one. That just seemed to be an easy place to find places or problems to work on. So let me just grab a brush here and start working. I've got a chemical equation here for something that you can't really make straight up the way that it is. Okay. So here it is. This is the formula that we want. It's 2 borons, right? Plus, I'm like getting sheepish because I can't see my periodic table right now. 3H2, so 3 hydrogens, 3 diatomic hydrogens yield B2H6. Okay. Now, the name of that compound is diborane. Okay. Now the name doesn't really matter so much. Really what I want to do is find out the heat just the same way we did in the last one, right? Okay. Now give me a minute here and I'm going to pull that up. Let me just, I'm going to paste that equation in so I can save some handwriting along with the associated heats. And let's see if we can make it work just like last time. Okay. Yeah, I know I don't have to go all graphically nice, but it's nice. So what you gonna do? Okay, so let's move that up here. I'm gonna stretch it out a little bit. Stick around, you might learn a little Photoshop while you're at it, right? Maybe. Maybe I will too. Okay, there we go. All right, so this is the problem we're gonna work, and let's hop to it. I'm going to start my substitutions right away, and I want to see how fast I can do it this time without making a mistake, because, you know, tests are timed, unfortunately. Okay, I've got 4. Maybe that would be easier if I wrote above like last time. 4A plus 3B yields 2C. Add a delta H equal to negative 2509.1. Okay, that's in kilojoules. It doesn't, that looks more like an orbital spin thing. Okay, the next one is, well, let's see, we don't have any H2, so that's going to be 2D plus B yields. There's no H2O up here, so that's going to be A, B, C, D, E, okay, 2 E's right here, and that's going to be delta H. I'm just copying it so it'll still show up when I erase that later. Negative 571.7. Here, let's be good. Put in our units. Okay, and the last one is B2H6. That's the, yeah, okay, so, oh, no. You know what? I screwed up, but we can work with this. We can work with this. I'm just going to keep moving. B2H6, we don't have that yet, but I'm going to call that F. Okay, I'm going to have to substitute that back up here on top. And oxygen, that's 3 B's. Not to be confused with freebies. And B2O2 is going to be just 1C. And heat on that one is going to be equal to negative 2147. I'm glad I did this on a different layer. Photoshop, I love you. Okay. And, I didn't see the 3 waters that wrapped over here. So plus, I need more room. Plus 3H2O, which is E, plus 3E. And now I can say that. Okay, now let's go back up here because boron, I had this here, and I'm going to say 2A. Looks confusing for the moment, right? H2, that was D, so I'm going to say 3D yields, and this is my target equation up on top. B2H6 is what we wanted in the first place, and that's down here. That's F. Yeah. All right. Okay, let's drop everything out from under it. That's what I want right there. Okay, now let's, you know, blue looks nice against an orange color, right? Start a new layer here, and let's start seeing what we can calculate. If this is what we want, and what down here is going to give it to us. So I can see an A right here. I've got 4 of those. Maybe if I only had half of this. Well, that sounds kind of tricky. Is there an A anywhere else I could grab? Doesn't look like it, so I'm going to have to do that. So let's say, actually, I'll just run half all the way through. So let's do that. Okay, so I've got 2A. I'm taking from right here, right? Plus 3 halves B yields 2 halves or 1C. And that's going to be delta H 1/2 times this. Okay, I'm gonna screw up. All right, now let's take a new line here and see what we get. So that takes care of A, right? Because I've got 2A here and I've got 2A here. I want 3D. Where can I get 3D from? Well, I've got 2D. That's almost it. So if I said 3 halves of this one, right? If I can multiply that by 3 halves, I'd end up with a 3. Is that what I wanted? Yes, 3D. I confused myself there for a minute. So let's do it. 3 halves of this, those cancel out, so I would say 3D plus 3 halves B. I think something good's going to happen there, I hope. Okay, yields 3E. And because I multiply by 3 halves, I'm going to have to do the same thing over here. I'm not going to keep writing all that out. Negative 571 kilojoules, we're assuming, right? All right, and the next one we want will be, okay, so now we're good on A, and we're good on D, right? Because we've got D up here, so all I need really is an F. Where's F? Oh, here's my F. I knew they're going to have us flip one. So I'm going to have to flip that whole thing over, and I'm going to have to change the sign on this. I'm going to change the sign first because that seems to be a place I screw up. So I'm going to go 2147 kilojoules, right? All right, and now I'm going to take that equation, this one I said right here, right? Yeah. Okay, so I'm going to flip this over, and that's going to be C plus 3E. That's good. Yields... C plus 3E yields F plus 3B. I already changed my sign over here so I don't have to freak out. Time to draw a nice tidy line underneath it all. And purple. Yeah, purple will work. Sound effects are useful also. Okay, let's do our cancellations. I'm looking on both sides for things that match. It's like solitaire sort of too. Okay, well, 3 halves plus 3 halves is going to be 3, right? So that's 3B. That can come down. Wait, did I say that right? That sounds really screwy. Yeah, okay. That's 6 halves is 3. Yes, 3B, which cancels with this over here, right? So these guys cancel out because 3 and 3 on each side. Now the next part is 3E's. I've got those on each side too, right? So now I've got 2A plus 3D. Yields, what's left? Oh, hey, look, F. How convenient. Okay, now all I need is my calculator. I just checked HP's site yesterday, and I guess I'm going to have to go out and spend the 30 bucks. I don't know if this is a legitimate emulator, and I'm starting to feel a little guilty about that. So, even though I have 2 of their calculators, have I mentioned I have 2 HP calculators? Okay, yes, I'm very proud of them. Okay. So I'm typing in my numbers here, 0.1. I multiply that out. Why was it half? Because, well, because we multiplied by half, 3 halves to get, oh, wait a minute. Oh, that was almost a colossal screw up, right? That should, well, was it? No, that's right. That was almost a colossal screw up about a colossal non-screw up. Okay, and I didn't flip that though, so it could have still been a colossal screw up. This should have been negative. Okay. Okay, next line. 3, enter to divide. That's going to give me the 1.5 that I'm going to multiply this by. 571 times. That's 856. And then that one just goes right in, 2147. Oops, good grief. It's kind of hard to type with a stylus. 147. Is that it? Okay, I think we're good. Yes. So, plus 3590. I don't know about that. Let's see if that worked out. It's not that that has to be a bad number. I'm just, I'm kind of new at this and I'm a little nervous. I'm going to say actually that does look right. So it's going to be 35.95 kilojoules. And what's cool about that is I think we just came up with an endothermic reaction, right? Because if I have this and I add this and get this, and it comes out a positive number, that means heat went into the system, not out, and that's endothermic. And just for a little gut check here, I'll just pull in the gnarly mess that is the underlying equation and see. Oh, this is feeling familiar, huh? I've got to find a better method for this. I think this will do it. I say. All right. So if I look up at my equation, it doesn't really matter that even really what it said because, oh, good grief. We'll get there. We'll get there. Ah, that's better. Okay, so it doesn't matter what my underlying equation was as long as I'm consistent in the way that I put my variables in. I'm careful about my signs. When I flip things around, I should come out with a good answer. I hope that helps. I sure hope I can solve it in faster than 12 minutes on an exam, because that'll be murder. Murder. Bye.